So we're looking for log of 1 over n. Now, Ben has something to say about this problem. Ben, based on what Morgan showed you and the catharsis you experienced today, what do you think you could do with this statement? Cool. And we know that q equals log of n. And what's log of 1? 0 minus q, or negative q. Did anyone do it this way and say 1 over n, why that's n to the negative 1? And then use the power rule to bring that negative 1 down in front? And then say, oh, log n is q, so I have negative q. You could do the problem that way as well. Any other questions from this worksheet? No, and don't, I think you're conflating two things. You're conflating one log with division, which is log m minus log n, with two logs being divided, which is just two logs being divided. So this is p over q. Sorry. Wish it could be harder. Okay. But it certainly does say a lot about, like, I have to be comfortable with symbolic representations of these rules that we've been talking about for a few years, and to recognize that these aren't the same. This one is, in fact, on the piece of paper so that we don't think it's this one. And lo and behold, it was good to have that conversation again. Okay. Any other questions from this worksheet? Yes, please. Yes, please say when. That one? A little more. Is there more? Oh, there's more. Okay. Yes, ma'am. Yep. Any other questions? Okay, next one. What do you want to look at next? Logistic one? Oh, okay. I like the logistic one. It's only got 4 problems. Any questions about this logistic worksheet? Megan's got the smile. I know that smile, Megan. Do you know what that smile is? That's the smile of, I wish I had started this one already, because I bet I'm going to have a question on it. 3. Graphing it? Sure. We did a bunch of regression stuff while you were gone, so don't feel bad that you're not warmed up on that. Yeah, see stat here? We press stat, we do edit. I'm going to clear the list by going up arrow, clear, enter, up arrow, clear, enter. 1910. I'm going to put in 0. 1930 then is 20 years later. 1960 is 50 years after 1910. 1980 is 70 years after 1910. 1990 is 80 years after 1910. 2000 is 90 years later. And 2010 is, ooh, don't forget to hit enter. 2010 would be 100 years later. Okay, and then I put in some population for New York, 9.1 million, back when my grandfather was a child in New York City. My grandfather was a child in New York City in the early 1900s, and he described something which I think even you will all find amazing. Besides the fact that he was born just when the first airplane, thank you Wilbur and Orville, was being tested, and he died after the moon landing. Wow, that was a life. He describes a New York City, in addition to being a lot of people, where there were how many mail deliveries per day? The mail came 5 times a day. phones weren't common. You needed a more efficient postal service. Okay, 9.1, 12.6, 16.8, 17.6, 18.0, 18.9, and then finally 19.5. Okay, and this is, of course, not just the borough of Manhattan, but the surrounding communities. So you get this far okay? Now there's two more things you need to do to be able to see the scatter plot. One is to go to y equals and up arrow onto plot 1 and turn the plot on. Likewise, turning the plot off is important to do sometimes too when you get an error. And that's because the plot is turned on and it thinks you want to graph a scatter plot, but you really don't. So don't forget to occasionally turn the plot off. The other thing I would recommend is going over to Zoom and scrolling down to number 9 or just pressing 9, Zoom Stat. So here I get my data, and I'm supposed to ask the calculator for a logistic regression here. So I'm going to go to Stat, Calculate, Logistic Regression. Why, there's logistic. L1, L2, good. And I'd like you to store that logistic equation in, I've got some stuff in Y's 1, 2, 3, and 4 that I want to keep, so I'm actually going to put mine in Y5. It builds this logistic equation, and notice my carrying capacity, my C, is 19.77 million people, maximum population. Okay, so let's see what happens when we graph this. Pretty good fit so far. Okie doke. Do you need help with answering any of the 3 questions that are there? Okay, does anyone else have questions answering the 3 questions? Going once, going twice. I'm kind of interested in how we're supposed to, never mind. Good, nice, okay. Last worksheet then, which was the oldest one, the one that had even and odd on it and the table to fill in and the one logistic problem at the bottom. Oh, you do have a question, yeah. Yep. Yeah. Does it say find the rate? We did. That was that inflection point that I was talking with Grant about yesterday. And do you remember how we said we would find that inflection point? Can someone remind her how we find that inflection point? Chloe looks like she can. L over 2. So we want to graph L over 2 and then do second calculate intersect. Or if you don't feel like you've had enough algebra today, you could always do L over 2 equals your regression equation and then solve it algebraically. I myself would just do it on the calculator because it's clearly a calculator active problem if I had to do a regression. Okay. All right. Anything else? Okay. What about the last worksheet? Anything there that we should talk about? Okay. Great. Let's move on. Wow. We're just a week and a day away from our Chapter 1 test. So today's the end of pre-cal. We're summing it up with this carbon assignment and population assignment that you picked up from the cart on the way in. Tomorrow we'll start trig. We'll do trig for a couple of days. We'll review for our test, and then we'll take our test. Please note that there's a problem on the front, problem on the back. Okay. So carbon. Some people asked me about carbon, and they said they wanted some more. They wrote in their summaries that they kind of wish they knew more about this. They feel like they're not quite educated enough. They've heard a lot of things, but they don't necessarily have a lot of data of their own. And so I went to the NOAA website. That's our government, National Oceanic and Atmospheric Administration. And they've been gathering all kinds of data for quite a long time now. We've got surface temperature anomalies 1880 to 2011 here. And you can tell when they started doing the comparison because that's where the zero line is. And they noticed that in the past, the temperatures seemed to be at least a degree, maybe almost 2 degrees cooler than they were, but we seem to be warming up on average. And they backed that up with this. They gathered data both on land around the planet and in the oceans around the planet, and they looked across the same period of time, and they noticed even if you average land and ocean or look at them independently, we still seem to be going from a place where the temperature has gotten progressively higher on the planet. And it's still, we're only talking about a degree centigrade, a little more than a degree centigrade. I mean, how bad could that be? That shouldn't be that big a deal. But other people have suggested that carbon in the atmosphere is kind of problematic. And so this is the data from our observatory on Mauna Loa, which has been gathering data since is it 59 or 55? 59. They started measuring the amount of carbon in the atmosphere. They measure it in, I'm clearly not Hindu. They measure it in parts per million. That does seem to have a positive slope to it. As time has gone by, the amount of carbon in the atmosphere seems to be increasing. Anyone want to comment on this shape? What do they think they see? What's happening there? Bip, 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 bip. Well, that's a great question. Oh, say it again. Seasons. Winter is one, summer is the other, based on, trapping ability. Yeah. This is what? This is Hawaii. I don't know how many seasons they have in Hawaii. I like to think it's 4, but maybe it's always the same in Hawaii. But yeah, they do. So, so here we see, we're getting almost to 380. In 2004, we were at 377.38. And then you read the article, and many of you noted that the article data was a little concerning. And the article was not written this year. And if we go to the Mauna Loa website, which you can do, we find out that they update it all the time. And look, I mean, it really just is. I've been doing this conversation for a couple of years now, and yeah, it's almost 2 parts per million per year. Yeah, we just, well, the thing is, what I find a little disturbing about this is that we, the planet, in, excuse my language, a kind of half-assed way, are kind of doing some stuff to kind of try and address. Like, I don't know if you noticed, but we've got all these solar panels now. And I don't know if you've noticed, since you were a little kid, TUSD schools, they got solar panels now. That didn't used to be there. But that didn't change this. Because there are other forces at work. It's a lot of things are happening. And I don't know enough to say, geez, is this one of those things that just gets worse and worse because the more you have of it, the more it gets? Or is it maybe more a function of, wow, the population now is much bigger than it used to be, and each of those people plugs into an outlet, drives car, creates more carbon into the atmosphere. Just by existing, they have needs, and to fulfill them, we're using carbon-based resources to do it. Now, some people say, well, Mr. Kukla, this number surely is not a problem, and I kind of am, not really bothered by the 450 number. We've seen this before on the planet, and I gathered some data for you. Here's some data. This is the last 500,000 years. Ice core samples done by Russia and the United States, measuring carbon parts per million. What's the high point in the last 500,000 years? Yeah, we're way beyond that now. Now, we can see all the ice ages and warming periods for the last 500,000 years here. We've never been here before. And to us, it looks like just another day outside. But the planet is definitely experiencing newness. And I think it's worth our attention to note. I have some pictures here. These made for nice postcards. We have the photograph of the Shepherd Glacier at Glacier National Park from 1913, and then again in 2005. Not much glacier now. Yes. Calved. Mm-hmm. Yeah, and that, yeah, this used to be a glacier, and now it's a lake. I like when they take the picture in the same place, and you can see, like, wow, there's that mountain still there. That things have definitely changed, and maybe aside from European ski resorts, maybe we shouldn't be worried, except that we understand that we rely here in Tucson on the snow melt in Colorado. And if there isn't snow up there to melt, to come down that river, for us in California and the other states around here, heaven forbid, the poor farmers in Mexico who might want some of the river that used to come their way, we're in really big trouble. And I don't know if any of you actually clicked on that link I sent out. I think it was last Friday on the GroupMe. I was driving home and they were doing this article on the local news about water and what we're going to do, and it seems that we've built some basins to catch some water and to store our water bank for that day when the straw runs dry. Well, it turns out that we've built the basins, but we haven't actually built the infrastructure to get the water out of the basins and back into the aquifer. Because people thought the problem was so far down the road. And I heard the people on this report, these are the people who are running these facilities, saying, based on Lake Mead now, we think we're going to need to be drawing on these reserves, not in 40 or 50 years like we thought, but in 2022, which was part of the reason they were running the report. So I found that a little disturbing. But speaking of calving and the melting, it turns out that a lot of Greenland is glacier. And what we see here is the annual average melt from 79 to 2007. Some high melting over here, not much melting over here. By the time we got to 2012, we see a lot more annual melt off. There's a great concern that when the Arctic melts, and when Greenland melts, the sea levels just from those two locations, not including the wonderful melting in Antarctica, but that's a continent, so we know there's ground under there somewhere. When this stuff melts, there's going to dump so much fresh water into the oceans that suddenly the levels are going to rise, the chemistry of the ocean will change, the currents will stop flowing, uh, yeah, it's really kind of like that could be really bad. I hope we don't get to that place. But wait, because then there was this one, and I just kind of have to show you this. Um, Google has this wonderful app available on Google. Well, it's attached to Google Maps, but you can go here and move the water level rise and go around the planet and see what it would look like. Like Miami. What is Venice? Well, certainly Venice is, what an interesting place to build your city. Um, but yeah, Miami's having a problem with, oh, sorry, so all this purple stuff this is underwater now. Um, but that's 7 meters. That's like our worst, all the ice melts scenario. But more conservative, we will go with 1 meter. And let's go back to the United States and take a look at what happens there. There are problems in Florida right now because of rising water levels, in particular around Miami. See this water up here? This is the fresh water for Florida. Lake Okefenokee. It feeds the Okefenokee Swamp and usually drains out to the ocean. But as the water level has started to rise, what's happening is the ability of that fresh water to drain down, not happening anymore. It's backing up. And so the people from Miami are having a harder time securing their fresh water. They don't really know about this because they turn on the tap and it runs, but the people who run their water authority have definitely run into this. I'm from New York, and when I look to see what happens in New York with 1 meter, it's a little changed at 1 meter. Downtown Manhattan, a lot of that new construction with all those beautiful buildings, there's the Freedom Tower, so that's not going underwater yet, is going underwater. Whoa, look at that. Part of New Jersey is just not having fun. And there's the Statue of Liberty. It's just a little dot now. Uh-oh, that could be a problem. Um, there was, I noticed, a plan being talked about recently to build a floodgate across here. Actually, I think they wanted it to go across here, like the floodgate that they built in Venice to try and keep them from going underwater. Um, it would be 5 miles long, but the problem is that this is the end of a river, and the river drains, and if you put a floodgate, the river doesn't drain, and suddenly you sink Manhattan behind the lake of your own making. So, yes, sir. Yes. Yes. Yeah. I would say if projections for glacier melt continue the way they have, glacier scientists are saying unprecedented melting, even faster than they had expected, much faster than they were expecting the conservative situation to occur where it just sort of melts slowly, but it's melting faster than their worst case scenario was. So here's LA. I think this is LA, Huntington Beach. It doesn't seem so bad with 1 meter, maybe a little stuff along the coast. Um, yeah, I'm not worried about one. What about Santa Monica? Do we still have a pier? What? Maybe we still have a pier there. It looks like PCH might be in trouble in some of its sections. That could be problematic. But when you start increasing to 2 or 3 meters of rise, things start changing um, around the city. and it's going to become harder for some people. Um, yeah, so I just got to go back to this thing about I've been watching this number. I've been watching this number here on Mauna Loa tick up 2 parts per million a year, and we're just so far above where we ever have been before. And I would say we have been at 450 and above before. If you go back to the period of planetary volcanism, where, it was just a bunch of volcanoes spewing stuff all the time, yeah, that's when we were there. But no time since creatures have we been to the scary place before. And I would like not to get there. But I also know this. I'm going to retire in the next decade. It's only going to be so bad for me ever. I'm just not going to live that long. But you guys, 2050? Guess whose adult problem this is? So I want to say this about this problem. I want to say, look, there are lots of problems like this out there waiting for you. And your response to them, whatever the problem is, will be your response. Sometimes solutions are foisted upon us. Sometimes we can be part of a solution. Sometimes we say, I'm going to leave that to someone else to deal with. Sometimes we say, no, I need to step up and do this. What I do know is you can't solve all the world's problems. But I will also say this. I now, with the best guilt I can muster, say, no, really, you have to fix a problem in the world. I don't care which problem, but you need to make a life for yourself that addresses a big planetary issue or a big local issue, some issue, and work to make it better. I don't care what the issue is. My father started with me. I dropped a piece of litter when I was 6 on the ground in New York City. He went up and he kicked me in the shin with his steel-toed boots, and I said, "Ow, what the hell did you do that for?" And he said, "Your job is to not leave this place messier than you found it. Your job is to leave this place not as messy as you found it." Okay. Yeah. I'm sorry, I didn't hear you. Yes, I did. I don't know that I want to be on that train. Okay. Um, so, cure cancer, fix AIDS, feed all the people. All the people. Hey, maybe we could reduce carbon levels by killing some people. That's kind of tough. Because, the kind of level of killing you need to do is you need to bring us down to half our planetary population. And just the mechanics of carrying out that kind of thing, there's no easy way to do that. I mean, talk about something that he could have talked about. You think it's going to take a couple of terawatts to build those solar farms. Just imagine the amount of energy it's going to take to kill all those people. Yes. Well, and isn't that an interesting dilemma? Isn't that an interesting dilemma? It's sort of like maybe we should be having forest fires and having those burns and just burning it all out and just coping with it. Well, the problem with that is, and let's go back and look at this data for a moment. Have you heard about World War One? I'm not saying that facetiously. Are you familiar with World War One? A bunch of people died in World War One. Tens of millions of people died, especially civilians, lots of civilian casualties in World War One. But even more than all the casualties in World War One were the casualties that we had from the flu epidemic from 1918 to 1921. more people died from that than from the war. It's called the Spanish flu, but really it's the Americans brought it over when they went to World War One. And yeah, tens of millions of people. But this data doesn't change. I mean, when we look at our planetary population data, if you look at a graph of planetary population data since 1804, we will see that World War II, World War I, tens of millions of people dead. Long term, no change in the growth rate. Oh yeah, it's completely separate from carbon conversation. Just the population of the planet. The population of the planet, even when you put in wars, even when you put in tens of millions of people dying from this epidemic, planetary population is going like this. People like to have sex. Or will it be logistic? So I ask you here to consider some data points for world population and to build a model. Build a model. Build exponential regression. Build a logistic model. Tell me what you think about each in this situation. On the back, we're looking at this carbon data, and we're answering some questions about this carbon data. Okay? I would like to say a little bit more about world population models, but I think I'm going to wait a day or two until you've had a chance to do this and come up with your own models and think about it a little bit more. But there's some really interesting information out there about world population projections. I will tell you that when I was in elementary school in the early 70s, awareness of this problem had become new and was out there. Like, I have an early memory of we're worried about the size of planetary population. We were all very happy when China said 2 children max. Yeah, China took that away, by the way. Okay. But we were worried then about the increase in population. And I'd kind of like to come back and say, what were we worried about then as the population? Where are we now and where are we headed as we continue this? So how much time we got left? 15 minutes? There you go. Well, so it is scary, and that's why a lot of people say, I'm busy, and focus their attentions on work or family or video games. And other people say, no, that's not happening, because that's their way of coping with it. But we have an awful lot of evidence for the last 500,000 years. It's hard for me to argue that. Yes? We should fund public education better. Should's a good word. My high school history teacher said to me when I used the word should implies a moral obligation. Who are you obliged to in that statement? Who are you obliged to? Obliged. Who are you beholden to? Who do you owe something to that you should? Your kids. It's so easy for you to say, but you guys screwed it up. You need to fix it. And yeah, guess what? I just had that life, and I said that when I was there, and then what do? Well, you know, there are recycling programs now. Oh, that kind of work, and sometimes don't, and sometimes do, and that kind of helps. And we've put up all these solar panels, and that kind of helps. But we're now pulling out all this really not good for the environment fuel from fracking. That just is so carbon laden. It's not good. Yes, but it makes for cheap gas. Yeah. I spent 2 years on a bike going around Tucson. That's a tough model. Yes. Okay. Hi. Please. Well, and that's why I've given you different options because um, some people think about this problem differently, and depending on the one you choose, these numbers will be very, very different. Right. Because you're saying the year zero. I got a baby Christ, and I got this. And I agree, that's a population of zero. And it doesn't make sense. So that's why I have to understand what I'm building in here is a best fit model. No, no, use that one. It's not good for the year zero, but does it fit this data? That's what we're concerned about. Yeah. Whoa, overflow error. Whoa. That's kind of sad. Yeah, I guess don't use that model. I want to go look up the planetary population estimate for the year zero. Yes. Yeah. You would then split it with the product rule.